Hey everyone, and welcome to this explainer. I'm absolutely thrilled to have you here. Get ready because today we're stepping into what I like to call one of the greatest locked room mysteries in the history of science. We're going to uncover the invisible, almost ghost-like forces that literally power the modern devices sitting right in front of you.
Okay, let's just dive right into it. With a paradox that totally baffled the greatest minds of the 19th century. How exactly does electricity flow through empty space? I mean, we're taught that an electric current is just the physical movement of charges, right? Like electrons flowing down a copper wire. So, how in the world can a current seemingly jump across a physical gap where absolutely zero matter exists? To get to the bottom of this mystery, we really have to look at where the rules of the universe seem to just crack.
Section 1. A flaw in the physics. When the math breaks. So, for a long time, physicists relied heavily on Ampere's law. It's this fundamental rule of electromagnetism that links electric currents to magnetic fields. And honestly, it worked beautifully for steady currents, like water flowing smoothly through a pipe. But beneath the surface, it harbored a glaring, massive flaw. If you take Ampere's equation and apply a mathematical operation called a divergence to both sides, things go completely haywire. On the left side, the strict rules of calculus dictate the answer is exactly zero. But on the right side, using the continuity equation, the answer is the rate of change of the charge density. What does this actually mean? It means that unless the charge density is perfectly constant, Ampere's law completely breaks down. If the amount of charge is changing over time, the two sides of literally the most fundamental equation in electromagnetism simply do not match up.
Section 2. The capacitor conundrum. The ultimate crime scene.
To see this mathematical flaw play out in real life, we just need a rapidly changing charge, something like a simple charging capacitor. As a real physical current flows down the wire from the left, positive charge rapidly builds up on one plate and negative charge builds up on the other. So the current is flowing in and it's flowing out, but what on earth is happening inside that gap? Zero, exactly zero, actual physical charge is crossing that empty gap between the plates. No electrons are jumping across that divide. And yet, the circuit works perfectly fine. The magnetic fields around the wires act as if there is a continuous loop of current flowing. And this brings our mathematical contradiction roaring right into physical reality. To calculate the magnetic field using Stokes' theorem, we draw this imaginary loop around the wire. And we can cap that loop with any surface we want to measure the current passing through it. So on the left, if we draw a flat, disc-like surface, it clearly catches the real current flowing through the wire. Makes perfect sense, right? But look on the right. If we draw a bulging, bag-like surface that passes through the empty gap between the plates, it catches absolutely zero physical current. Just by changing our imaginary surface, the current mathematically vanishes. The laws of physics were completely broken here. Section 3. Maxwell's phantom current, the electric disguise. To solve this incredible contradiction, the brilliant James Clerk Maxwell stepped onto the scene. And he introduced this incredibly ingenious invention called the displacement current. Basically, it represents the rate of change of an electric field, which mathematically acts exactly like a real physical current. You can kind of think of it like a traffic jam on a highway. When brake lights flash, that wave of red lights travels backward through the traffic. The cars themselves, the physical matter, well, they aren't actually moving backward, but a very real effect is propagating through the space. Maxwell realized that a changing electric field propagates an effect that acts exactly like a current. Now, I gotta point out the irony here, because displacement current is actually a terrible name. It's not a real current at all. There's no actual physical charge being displaced across that gap. It is quite literally an electric field in disguise pulling a fast one on the universe just to make the math balance out perfectly. Section 4. Bridging the gap, closing the loop. Let's take Maxwell's brilliant theoretical fix and apply it directly back to our bulging surface, let's call it S', stretching right through that empty gap of the capacitor. Remember, before, this surface caught zero physical current, completely breaking our rules. But now, even though no physical charge is crossing it, a massive flux of displacement current is passing right through that surface. So here's exactly how this plays out. Step 1, physical charge builds up on the capacitor plates. Step 2, because of that accumulating charge, the electric field in the empty gap intensifies over time. And finally, step 3, the rate of change of that electric field, the flux, creates our displacement current. And mathematically, this invisible phantom current perfectly, and I mean perfectly, matches the exact amount of physical current flowing into the wire. The gap is officially bridged. And this right here is the grand solution. That incomplete Ampere's law that failed us, it only accounted for real physical currents. But by adding the displacement current, we get the generalized Ampere's Maxwell law. Maxwell basically snapped the missing puzzle piece right into place. The equation is now perfectly self-consistent everywhere, all the time.
Section 5. Why it matters. The power in the empty space. Now, you might be sitting there thinking, okay, this is a really cool theoretical physics puzzle, but why should I care? Well, consider a standard RC circuit. When you close the switch, Kirchhoff's laws absolutely demand that the exact same current flows through all the circuit elements, and that includes the capacitor. But wait, we just established that physical current cannot cross that gap. This is the whole point. A capacitor literally needs displacement current to function within our laws of physics. It's this phantom current that conceptually continues the circuit right through the gap, ensuring that our foundational rules of circuit design actually hold true in the real world. But honestly, the implications go way, way beyond basic circuits. Without Maxwell's phantom current, alternating current, the AC power currently running through your home, it simply wouldn't make sense. And even more profoundly, this changing electric field generating a magnetic field, which then generates an electric field, that is exactly what allows radio waves, Wi-Fi, and light itself to travel through the empty vacuum of space. Without displacement current, the very screen you are using to watch this explainer on simply could not exist. No way.
Which leaves us with this final, beautiful thought to ponder. We started all of this by looking at a tiny flaw in an equation, and we ended up discovering this invisible bridge across empty space that literally holds our modern world together. So, if an empty gap can carry a current, what else is hiding in the empty space around us? I really hope this explainer sparked your curiosity and showed you just how incredible the hidden architecture of our universe truly is. Keep questioning, keep learning, and thank you so much for exploring with me today.